After discarding or receive leaf sheets, still carding, Waller vs. Farther waste. Today, it begins its journey to become premium natural fiber.
It begins with a single, decisive strike. In the quiet of the morning, we harvest the strength that nature has spent seasons building.
Every leaf is returned to the earth, a natural cycle of nourishment. We only take the heart, the resilient core ready for its next life.
Welcome to the Forge of Nature. Here, we bridge the gap between ancient botanical wisdom and 21st century engineering. Precision is paramount. We calibrate to the millimeter, ensuring every segment is optimized for the extraction of its golden threads. From the grove to the laboratory, every stem carries a secret, a fiber stronger than steel, softer than silk. The journey to the future of fashion begins now.
The freshly cut pseudostems are loaded immediately onto trucks to reach the factory within hours, preserving maximum fiber integrity and preventing degradation of the long bast fibers.
At the factory, tons of fresh pseudostems are unloaded and sorted, beginning the zero-waste transformation process. It begins with raw power, a single calculated strike to harvest the water-rich columns that nature built over months of growth. In the humid agricultural zones of Southeast Asia, banana plantations operate as living production systems, each plant cultivated for a single harvest, and then cut down to make way for the next cycle. Behind every industrial material lies manual labor. Before machines, before processing, the work begins here, with human judgment, physical effort, and experience passed through routine. Fiber quality is determined at the moment of selection. Fresh pseudostems retain structural integrity, while delayed processing leads to rapid microbial breakdown and loss of usable material. Cutting technique is deliberate. Height, angle, and direction all affect the usability of the material and the efficiency of the next steps in handling. The pseudostem is not wood. It is a layered biological structure, and within its outer sheaths lie the long bast fibers used in textile production. Standardization begins in the field. Uniform length and basic grading improve downstream processing efficiency and fiber consistency. Once harvested, banana pseudostem begins to degrade within hours. Industrial processing depends on rapid intake, strict selection, and controlled handling to preserve fiber integrity. From this point forward, time becomes the limiting factor. Within hours, the material must be processed before biological decay begins to compromise fiber strength. Initial washing removes external contaminants. Clean surfaces reduce microbial load and prevent unwanted reactions during fiber extraction. Banana pseudostem is a layered structure. Each layer yields fibers with different properties, from coarse structural fibers to fine, silk-like strands.
Initial washing removes external contaminants. Clean surfaces reduce microbial load and prevent unwanted reactions during fiber extraction.
Mechanical decortication separates fiber from biomass. The goal is precision, removing soft tissue without damaging the long cellulose fibers within the banana pseudostem.
Initial washing removes external contaminants. Clean surfaces reduce microbial load and prevent unwanted reactions during fiber extraction.
Mechanical decortication separates fiber from biomass. The goal is precision, removing soft tissue without damaging the long cellulose fibers within the banana pseudostem.
Post-extraction washing removes residual plant matter. Clean fiber surfaces are essential for uniform drying and further treatment.
Enzymatic degumming breaks down natural binding agents within banana fiber. This step enhances softness while maintaining structural strength, a key advantage over chemical processing. From discarded banana pseudostem to structured natural fiber, the transformation is complete. What was once agricultural waste is now a viable material for sustainable industry. Not all banana pseudostem fibers are equal. Structural variation defines application, from high-grade textile yarns to industrial composites. Not all banana pseudostem fibers are equal. Structural variation defines application, from high-grade textile yarns to industrial composites. Through twist, loose banana fibers become yarn, a continuous structure capable of carrying load, tension, and form. Stability is engineered, not assumed. Conditioning ensures banana yarn behaves predictably under mechanical stress.
Weaving converts linear yarn into two-dimensional structure. With banana fiber, control is critical. Strength exists, but elasticity is limited. From banana pseudostem to functional material, the same fiber adapts across industries through controlled processing. At scale, consistency becomes engineering. Banana pseudostem fibers must meet precise dimensional standards before entering high-speed textile systems. Natural fibers are never identical. Blending transforms variability into controlled uniformity, essential for industrial textile production. Banana pseudostem, once discarded, becomes fiber, then structure, then product. A renewable cycle, engineered through both nature and industry. Modern spinning transforms banana pseudostem fibers into engineered yarn, balancing natural variability with mechanical precision. Warping defines the structural backbone of fabric. With banana fiber yarn, precision tension control prevents failure during weaving. Industrial weaving scales banana pseudostem fibers into continuous textile, where speed and control must coexist. Material performance defines application. Banana pseudostem fiber must meet functional standards, not just sustainability claims. From clothing to construction, banana pseudostem fibers adapt across industries through controlled processing. Structure defines behavior. The internal architecture of banana pseudostem fiber gives it unique mechanical and environmental properties.
Banana fiber shows higher stiffness than cotton and lower environmental impact than synthetics.
From banana pseudostem to finished material, a cycle of transformation. Not extraction, but regeneration. Industry aligned with nature. Scaling banana pseudostem fiber production requires more than machinery. It demands synchronized movement of material, data, and time. Failure is data. Every broken banana pseudostem fiber reveals a weakness in process and an opportunity for refinement. Blending expands capability. Banana pseudostem fiber adapts, not by losing identity, but by integrating with complementary materials. Automation accelerates inspection, but final quality still depends on human interpretation of banana fiber behavior. Application defines requirement. Banana pseudostem fiber must perform not just in production, but in everyday use.
Technology scales production, but human experience defines quality. Banana fiber still responds to touch, not just measurement.
Sustainability is engineered. Banana pseudostem fiber reduces waste, but only when the entire system is designed to support it. From local plantation to global market, banana pseudostem fiber enters the international supply chain as a competitive material. What was once agricultural waste is now engineered material. Banana pseudostem fiber represents a shift from extraction to regeneration, from disposal to design.